Great. So anyway, good afternoon, students. Whether my screen is visible, am I audible?
Yes, sir.
Excuse me. Okay, right. Good afternoon, students. Welcome to the module 25, right? In the IC engine subjects, right? So in this module, we can see the combustion chamber design for the CI engines, right? So why the combustion chamber is very important means uh, we have many objectives on the combustion chambers, right? So in the CI engines, in the CI engines, uh, during the suction, compression, and the induction, right? So during the suction, induction, and the compression process, the only the working substance will be the air, right? So only the air will be sucked and it will be compressed, right? And the fuel is injected through the injector at the end of the compression stroke, right? So the time available for the vaporization and the mixing with the air is very limited, right? So the time available for the vaporization and the mixing of fuel and air, fuel and air is very limited, right? So also for the better mixing and the better combustion, right? So the air swirl is required, right? Air swirl is required for the better combustion, right? For the better combustion, the air swirl is required, right? So the for the better combustion, the atomization, vaporization, and the proper mixing with the air is required is minimum, right? Is required is minimum time, right? So and it results, it will gives the high power, better efficiency, smooth and noiseless engine running, and the shorter delay period, right? So which reducing the probability of the knocking, right? So the designing is very important one. Why? Because the air swirl, right? So air swirl is very important one. Why? Because we have to mix the air and fuel in greater manner, right? For the better manner, then only we can achieve some the maximum power, better efficiency, and smooth and noiseless engine running, right? So that may be occurring, that may be obtaining by the better combustion, for the better combustion. So for the better combustion, the air swirl is very important one, right? So for the better combustion, the air swirl is very important one, right? So just we can see, right, what is air swirl, right? So for the proper mixing of the fuel and air in the combustion chamber, in various methods are there, right? So the various method of the air movement will be called as the air swirl, right? Will be called as the air swirl, right? So it's an important 2 mark question, right? It is an important 2 mark question. Remember that one, right? So for the proper combustion, for the better combustion, right? So the for the better combustion, it may gives reducing the knocking tendency, right? It reducing the knocking tendency. It improves the efficiency, right? So if the better combustion will be there means the engine noise will not be there, right? So it will be runs by smooth manner, right? So for the proper combustion, right, surely we required air swirl, right? What is air swirl? It is a proper mixing of the fuel and air in the combustion chamber. The various methods of the air movement, various methods of the air movements are employed, right? That is called as air swirl, right? So in that air swirl, we have three types of air swirls, right? One is the induction air swirl, compression air swirl, and combustion induced air swirl, right? So we have three types of air swirls will be there, right? So remember that one. So what is air swirl? Air swirl is a mixing of the fuel and air in the combustion chamber. It's a method, right? It is a method, right? So for that, what are the different methods and what are the types will be there that we can see, right? So the first one is the induction swirl. First one is the induction swirl, right? So in this method, the swill is provided. The swill is provided to the incoming air to the cylinder during the suction stroke. Right, during the suction stroke. That's why it's called as the induction swill. Right. So in this diagram you can see. Right. So in this diagram you can see it is the inlet manifold. Right. It is the inlet manifold. Right. So here the air will be coming through the cylinder by this way, right, by this way. For opening this valve, the air will be coming through this way, right. So it is one type of method, right, it is one type of method. So while the air will be coming through this port, right, so how the air movement, right, how the air movement will be there, right. So which is directly coming to the air to the combustion chamber, right. So here we have a different type of swirls, right. Here we have a different type of swirls to the incoming air, right. So in this diagram you can see the second one, right. So in this diagram how the air will be coming, you can see. So here we have some mask or a covering, right. In this part you can see, in this part here one mask will be there, right. So the mask uh, stops the airflow to the combustion chamber, right. So only the airflow through this opening, only the airflow through this opening, right. Is it clear or not, right. So the air is enter only around the part of the periphery, right, around the part of the periphery of the valve. So the air swirl is produced, so the air swirl is produced, right. So what will happen, the air will be passing through the valve by around the valve, right, around the periphery of the valve, right. So usually the mask, the covering portion, usually the mask covering portion will be 90 degree to 140 degree, right, it will be used, right. So for the better tangential action, right, so for the better tangential action of air movement can be obtained by turning, right. So in this method, right, the third one, right. So for the best tangential direction of the air movement can be obtained by the turning the valve around its axis, right. So the valve will be rotate, the valve will be rotates, right, while it is in opening. So what will happen, it will be rotates and it will opens, right. So by illustrating this method, right, by illustrating this method, the producing the air swirl by the casting of the lip on one side, right, lip on the one side of the inlet valve. So the air enters from the top and it will due to some lip, so the air swirl may be occurs, right. So this type of induction is called swirl, sorry, induction swirl, right. This type of air swirl is called induction air swirl, right. Then the second one is the compression air swirl, right. So for the suction stroke, right, for the suction stroke, I already told that. So the combustion chamber design is very important. Why? Because in CI engines, right, in CI engines, the induction, that is a suction, right. So for the suction stroke and the compression stroke, the only the working substance will be the air, right. Working substance is, right. So here while sucking, right, while sucking the air has to having some air movement, right. So that is called the induction, that is called the induction air swirl, right. So for the compression stroke, for the compression stroke, again the air has to swirl, right. So then only the proper mixing will be obtained, right, then only the proper mixing will be obtained, right. So the proper mixing of the fuel and air is very very important one, right. So we have to mix the fuel and air in a proper manner, right. So we require these air swirls, right. So the first one is the induction and second one is the compression air swirl, right. So in this method the air swirl is produced during the compression stroke, right. So during the compression stroke the air swirl is produced, right. So here you can see at the top of the piston, right, it is, it is the combustion chamber and it is the piston, right. So either it is visible,
Yes, sir.
right, right. So it is the piston and it is the combustion chamber, right. So here we have a shape, right? So that shape, right? Due to that shape, what will happen? The air will be uh, the air swirl will be maybe occurs, right? So here you can see at the top of the piston we have the different shapes or different cavities which is formed by the different shapes and different sizes, right? So due to this, what will happen during the compression stroke? During the compression stroke, the air may be get some movement, right? So that is called as the compression swirl. That is called as the compression swirl, right? Then the combustion induced, right? So in this method, the swirl is produced by the high pressure which is generated during the first part of the combustion of fuel, right? So remember that one, it will be produced by the high pressure generated during the first part of the combustion of the fuel. The piston head have the different types of the design, right? So which will help to generate the swirl during the combustion, right? So most probably it is called as the pre-combustion, right? It is called as pre-combustion or air cell combustion chamber design, right? So it will be due to the pre-combustion of the air swirl, right? That pre-combustion air swirl may be explained in the later slides, right? So the proper mixing, right? The proper mixing of the air and fuel, right? So here we have uh, air swill, right? Here we have air swill for the proper mixing of the air and fuel, right? So for the better combustion, for the better economic level, right? So the combustion chamber, the chamber design is a very important one, right? So the combustion chamber is a very important one, right? So here we have a different type of the combustion chambers, right? So the first one is the open combustion chamber or the direct injection combustion chamber, pre-combustion chamber, then the turbulent combustion chamber and special combustion chambers, right? So here I already told that, right? So what is the open combustion chamber and what is the pre-combustion chamber, right? So these two I already told, right? What is that? While in the nozzle portion, while explaining the fuel nozzle, that is the injector, right? So while explaining the injector, the we have four type of the nozzles, right? What are the nozzles? Single hole nozzles and multi hole nozzles, spindle nozzles and Pintlex nozzles, right? So the single hole and multi hole nozzles will be used in the open chamber, right? Open combustion chamber. And for the Pintex nozzle, we are using the pre-combustion chamber, right? So that will be, I already told that one, right? Just to may remember this, right? So here in this classification of the combustion chamber, we have four types. That is, we have four combustion chambers, right? One is the open combustion chamber, right? Open combustion chamber, or it is called as the direct injection combustion chamber, and the pre-combustion chamber, turbulent combustion chamber. That turbulent is called as the indirect injection, right? It is called as the indirect injection, and we have some special combustion chambers, right? Just we can see one by one. So the first one is the open combustion chamber. The first one is the open combustion chamber, right? So in the open combustion chamber, the space between the piston and the cylinder head is open, right? The space between, see here. So in this diagram, you can see this portion. This portion is called as the combustion chamber, right? So the space, right? So the space between the piston and the head, right? So this portion is called the combustion chamber, right? So in this open combustion chamber, the space between the piston and the cylinder head is open, right? It's open, so there is no restriction between this, right? So there is no restriction between, right? So therefore all the air is contained, in space between the piston and the cylinder head, right? So whatever may be, right? So whatever may be the working substance, right? So the inlet valve will be open, means, so what will happen? The air, right? So if the piston will moves from TDC to BDC or BDC to TDC, right? So the space between the piston and the cylinder head, right? So all the air is contained the space between the cylinder and the cylinder, sorry, piston and the cylinder head, right? So the fuel is directly injected. The fuel is directly injected to the combustion chamber, right? Is it correct or not? So this type of the combustion chamber is called the open combustion chamber, right? So see here, you can see here. So all the injectors will inject the fuel directly in the combustion chamber, directly in the combustion chamber, right? So this either the combustion chamber may have a different shapes, right? The combustion chamber will have the different shapes, but it is open combustion chamber, but it is the open combustion chamber. Why? Because the fuel injector injects the fuel injector injects the fuel open to the combustion chamber, that is open to the space, right? Open to the space between the piston and the cylinder head, right? Piston and the cylinder head, right? So here we have different type of crown. So this, the top of the piston, the top of the piston is called the crown. The top of the piston is called crown, right? So here you can see the different shapes, right? Here you can see the different shape, right? So here the piston shape will be a different, right? So here in this diagram you can see here the head also having the different shapes, right? Here the head also having the different shapes, right? So we have different type of open chambers, right? We have different type of open chambers by the cavity which is presented in the piston head, right? Piston top of the piston, that is called the piston crown, right? So here the fuel will be directly injected to the chamber, open chamber, right? So this type of injection is called direct injection or a open chamber, right? So here also we have some silent features and advantages and disadvantages, right? So for the silent features, so the less turbulence is generated in this type, right? So that is the important one, right? So if it is the less turbulence, so the heat loss will be the less, right? So if the turbulence will be more, so the heat loss will be more, right? So it is here the silent feature of, right? So here the less turbulence will be generated. So due to the less generation, so the heat loss is also a less, right? So it is easy. Starting is very easy one. Starting is very easier one, right? Then the excess air required is very more. The excess air required is very more, and so the size of the engine is increases, right? So the size of the engine is increases, and if the size will be increases, then the thermal efficiency also increases, right? Then its size is increases, so the large capacity and the speed maybe varies, right? So this type of the open chambers will have a large capacity, and we have the low speed engines, right, which is used in low speed engines. So these are the silent features in the open combustion chamber or a direct injection combustion chamber, right? And here we have some advantages, right? So if the excess air is required, right, if the excess air is required, so the engine size is increased, and plus the thermal efficiency also increases, right? So the advantage is the thermal efficiency high because of the heat transfer is, which is very low. Heat transfer is very low, right? The heat transfer losses, right? Sorry, heat transfer losses will be low, less, right? So the thermal efficiency will be high, right? Then it is very easier to starting because of the heat transfer is very low, right? Then the shape will be very simple, right? The shape will be very simple, right? So simple in construction, right? So in case of the slow speed engines, the less costly of the fuels, it can be used, so the longer delay can be used, right? So with a longer delay it can be used, right? So these are the advantages. And for the disadvantages, whatever maybe the efficiency will get very high, but at the same time the size is very more, right? The size is very more, right? So that's a very difficult one, right? So to handling the very size and the space utilization is very high. So the engine size, it's become very large, right? It may have some excess air is required to generate the same power, right? To generate the same power, right? So the silent feature here is the less turbulence, right? So the due to the less turbulence, the direction injection pump pressure is required for the multi-hole nozzles, right? It will require for the multi-hole nozzles, and the maintenance cost is high, right? So the maintenance cost is very high, right? So this are the silent features and the advantages and disadvantages of the open chamber, that is open combustion chamber or the direct injection, right? Then the second one is the pre-combustion, right? So the working of the diesel engine, I already told that the pre-combustion will be used, right? So why the small additional chamber, the small additional chamber? So it is the additional chamber, right? It is the additional chamber, right? So for example, just wait, right? So for example, I kept the injection nozzle here, and I will spray the nozzle. I will spray the fuel here, right? I will be cut off, right? So this type of chamber is called the open chamber, right? So here we didn't use any extra additional chambers, right? So if you are using the additional chambers, right? If you are using the additional chamber, that additional chamber is called the pre-chamber. So here I'm using the pre-chamber, a pre-chamber, right? So small additional chamber is called the pre-chamber, which is connected in the main combustion chamber, right? Which is connected in the main, right? So which is connected in the main combustion chamber. It is the main combustion chamber, and it is here. It is a small chamber, that is a pre-combustion chamber, right? So where the fuel is injected in the pre-combustion chamber, right? Where the fuel is injected in the pre-combustion chamber, right? So this main combustion chamber and the pre-combustion chamber, which is connected, right? Which is connected with a small hole, right? So the main combustion chamber and the pre-combustion chamber, which is connected by a small hole, right? So the fuel is injected, the combustion starts at the pre-combustion chamber. The combustion starts at the pre-combustion chamber, and the products of the combustion is through the small hole to the main chamber, right? To the main chamber. So with a high velocity, it will generate the turbulence, right? It will generate the turbulence as well as the air movement, swirl, right? So air movement, that is called the air swirl, right? So which produces the bulk combustion in the main chamber, right? So it's about 80% of energy is released in the main chamber, right? 80% of energy is released in the main chamber, and for the 20% of energy released in the pre-combust chamber, right? So the first combustion starts at sorry. So the first combustion starts at the pre-combustion chamber due to the high temperature of the surrounding air, and it will propagate to the main chamber, right? So thus the delay period is reduced, right? That the delay period is reduced, as well as the poor grade fuels, right? Poor grade fuels also burnt in a easy formation. Easily it will be burned, right? So if it is a less number of cetane number, so that fuel also we can burn, right? We can burn in a easy manner, right? By using the pre-chamber, right? So here also we have some advantages and the disadvantages, right? So fuel with a wide range of the cetane numbers can be used here, right? So why? Because if the cetane number is less, that fuel also we can easily burn. Why? Because we are using the pre-chamber, right? So in this pre-chamber, what will happen, right? So the fuel, the initial fuel, the first fuel will be burned here itself, right? So here itself we have to burn, means the fuel amount will be somewhat high, right? At the same time, the air which is presented here is somewhat low. At the same time, what will happen? The temperature is very high, right? So during the compression stroke, due to the compression stroke, the high pressure air is generated. So due to the high pressure, the temperature also increases. That temperature, it's beyond the self ignition temperature of the diesel fuels, right? So it will be easily burned, right? So it will be easily burned, whether the low cetane numbers or a good cetane number, right? So the wide range of the fuels, right? The wide range of the fuels, it can be used in a pre-combustion chamber, right? As the injection pressure is low, right? So the simple fuel nozzles it may be used here, right? So either we can use the Pintlex nozzle, right? We can use the Pintle nozzles here. Most preferably, we are using the Pintle nozzle here, right? Then the smooth running of the engine. Then the engine can run at high speeds, very high speeds. You can use this type of the combustion chambers, right? So the delay period of the main combustion chamber is very small. So obviously, what will happen? The knocking tendency will be reduces. The knocking tendency will be reduces, and the engine will be runs in a good manner with a high compression ratio. So the efficiency will be somewhat increases, right? So these are the advantages. And for the disadvantages, right? So the engine design, it becomes somewhat complicated. Why? Because it will have some extra additional chambers, right? So the pre-chamber, due to the pre-chamber, the engine design, it's very complicated one, right? Then the heat loss from the pre-chamber is very high, right? So in the pre-chamber, it will be first burned. The first burning will be occurs in the pre-chamber, right? So the heat loss, it's also high, right? So due to the high heat loss, what will happen? The cold starting, right? So the due to the high heat loss, the cold starting is very difficult here, right? Then the fuel consumption is very high, and the thermal efficiency is somewhat low in the this type of the pre-combustion chamber. Right. What's the time? Okay, right. Again, I will have 15 minutes. Okay. Then the third one is the turbulent, right? Turbulent or the indirect injection, right? Turbulent or indirect injection combustion chamber, right? So these combustion chambers are similar to the pre-combustion chamber, right? So this is also a similar one, right? This is also a similar one for the pre-combustion chamber, right? So here the difference is that the pre-combustion chambers only 20 to 25 percentage, right? 20 to 25 percentage of the total air enters while in the combustion, right? So the 80 to 90 percentage of total air is circulated in the pre-combustion chamber, right? In the pre-combustion chamber, right? You can see here in this diagram, right? So here the percentage of air, right? So nearly it will be 80 to 90, or here I can mention 90 to 95, right? So the total air is circulated in the pre-chamber, right? Right. So at the high rate of the right, high rate of the air movement, that is called the air swirl, it will produce in this type, right? So high rate will be produced in this turbulent indirect sorry, turbulent or the indirect injection combustion chamber, right? So it is also called as a swirl combustion chamber, right? It is also called as the swirl combustion chamber, right? So here I can mention here, you can see, right? So it is also called as the swirl combustion chamber. Why? Because here the 90% of air will be circulated. 90% of air will be circulated. So once it is circulated means the air movement will be somewhat good. So the air will maybe occurs in the chamber, right? So it is also called as the swirl chamber, right? So during the compression stroke, the most of the air from the main chamber enters to the pre-chamber, and where the high rate of the swirl is produced, right? Where the high rate of swirl is produced, right? So then the fuel is injected. The fuel is injected in the pre-combustion chamber, right? And the ignition and the bulk of the combustion will be takes place in there itself, in the combustion chamber itself. So uh, the sorry. So what will happen if the combustion will be takes place in the pre-chamber, right? So again it will be easily burn the low cetane numbers also, right? Low cetane numbers fuels also you can easily burn, right? So here also we have some advantages and the disadvantages, right? So first we can see the advantages, right? So due to the high rate of the air swirl, right? Due to the high rate of the air swirl, right? So comparatively the rich mixtures, that is the low air and the fuel ratio, right? Low air and fuel ratio, it can be used, right? It can be used, and which makes the engine compact for the various output, right? Various output, and the large range of the cetanes will be used, right? So the wide range of the cetane numbers fuel, right? Wide range of the cetane number fuels will be used here, and the same the injection pressure and the pattern of the injection, it's not a very important, right? It's not very important. Why? Because here the swivel will be there, right? Here the swivel will be there. So here also we can use the simple nozzles, right? Here also we can use a simple type of nozzles we can use, and the slow maintenance cost, right? And it maybe have some low maintenance cost, and it will be run with good uh, smooth engine condition, right? Smoothly running and with a low maintenance cost, right? Then the engine can operate at a high speed, right? With a small delay periods, right? If it is the small delay periods, so what will happen? It will reduces the knocking tendency, right? Then here also we have some disadvantages, right? So the efficiency, it may have some low thermal efficiency, and the same the cold starting is somewhat difficult, and due to the large heat transfer, due to the lot more heat loss in the cylinder wall, so it will consume the high fuel consumption, right? It will consume some high fuel consumption, right? So these are all the disadvantages of the turbulent type combustion chamber or a indirect injection combustion chamber. And we have some special combustion chambers, right? We have some special combustion chambers, right? So that is, one is the MAN combustion chamber, and one more is the air cell combustion chambers, right? So these two are the special combustion chambers, right? So here I mentioned here MAN combustion chamber, right? So here MAN means a scientist, right? The scientist name is um, Massimo Ashleyberg and Nummerberg, right? So these three scientists, right? These scientists will develop this type of the combustion chamber. So here itself, that name will be MAN combustion chamber, right? It is developed at 1954, right? It is developed at 1954, right? So it is a special type of the open combustion chamber, right? It is, you can see here, the fuel will be injected the space between the piston and the cylinder head. So it is also one type of the open combustion chamber. It is also one type of the open combustion chambers, right? So which is it is very suitable for very small and high speed engines, right? Very small and high speed engines, right? So in this design, the combustion chamber has a cavity, right? So this cavity is very important, right? So here you can see the cavity in the piston crown, right? Cavity in the piston crown is a spherical cavity, right? It is a spherical cavity, right? So in this design, it's a very important one. We are using the spherical cavity, right? So the fuel sprays in the tangentially on the cavity, right? Tangentially on the cavity, and it will be spreads over the entire chamber, right? It will be spreads over in the entire chamber. You can see here. So the spray will be splashed here, and it will be passing through the entire chamber, right? So for that only we are using that a small spherical, right? Small spherical cavity in the top of the piston, right? So the piston crown, right? So the such type of the fuel spray, right, in pigment was developed, what undesirable, right? So it is an undesirable, right? So but here also we have some advantages and some disadvantages, right? So the large range of the fuels can be used here, and the poor quality of the fuel also we can use here with the low cetane numbers, right? Then for the better combustion will be here, right? So the better combustion and the low exhaust emission, and for the more brake power, right? So more power will be there, right? Because of the high volumetric efficiency, and it is used in a cold starting engines too, right? And there is no combustion noises will be there, and the low rate of the pressure rises, right? Low rate of the pressure rises, and for the disadvantages, the poor performance, and for the high emission at the low load engines, right? So it is especially for the small and high speed engines, right? So if you are using this chamber in the low speed engines, we can get some high emission, right? We can get some high emissions at the low load itself. So it is a very disadvantaged one, right? In the term of the emission, in the term of the emissions, in the term of the emissions, it's a very disadvantaged one, right? Then the second one is the air combustion chamber, right? So for the air cell combustion chamber design, which is used in the Lenovo engines, right? Which is used in the Lenovo engines, right? So in this case, the separate air cell, right? The separate air cell you can see here. Right. So the separate air cells will be there, right? So in this case, you can see the separate air cells, right? So through a small neck communicates with the main chamber, right? So small holes, right? So it is a small through, right? It is the small through which is connected to the main chamber, right? So the combustion is ignited, the combustion is initiated in the air cell, and it will due to the high pressure rises, and it will be flow back into the main chamber, right? So this type of engine will have some advantages, right? So the cold starting is very easier one, and the high rate of the swill is there, so the better mixing, so the better combustion will be there, right? Then the exhaust will be limited one, right? So exhaust emission will be the less one, and we can obtain the maximum pressure rise is low, right? So the engine will be runs at in a smoother manner, and we have disadvantage of the low thermal efficiency and the high fuel consumption. Why? Because the cylinder wall will may get some heated condition, right? So it will not used for the variable speed conditions, right? So it will be used for the constant speed condition. We are using this type of the air cell combustion chamber, right? So the combustion chamber design is very important one, right? The combustion chamber design is very important one. Why? Because um, only the air is a inlet substance, right? Only the air is sucked into the suction stroke as well as the compression stroke in the CI engines. So after that only the fuel will be sprayed, right? After that only the fuel will be sprayed, right? So the time available for the vaporization and the mixing is very limited. So for this condition, we are using the different type of the combustion chambers, right? So that only we are using the different type of the combustion chamber, right? So for the design of this combustion chamber, we have plenty of benefits as well as the disadvantages, right? So depending upon our condition, depending upon the load, depending upon the engine type, right? So we may prefer the different type of the combustion chambers, right? So most of conditions we are using only the two, right? One is the open combustion chamber, and for the pre-combustion chamber we are using for the most of cases, right? But in some special cases we can use the turbulent combustion chamber and the special combustion chambers, right? So for the commercial, most of the commercial engines we are using the open combustion chamber and for the pre-combustion chamber, right? So the combustion chamber design is very important one in the CI engines, right? As well as the SI engines also, the combustion chamber is very important one. So we can see the combustion chamber design for the SI engines in the next class, right? So in this class, do you have any doubt? Anyone? No, right, fine. So
No,
the
sir.
assignment 2,